Hello, and thank you for coming to my talk. Thank you to PyOhio for the opportunity to present. I'd like to speak with you today about a platform that I wrote, a series of programs that allows one to experiment with lights and sound. Please excuse the occasional video artifact. I'm working with some Motor Linux equipment that has served me very, very well. So what was the motivation behind this project? Around 20 years ago, I became aware of the existence of full RGB LEDs and their availability to the public. I was very excited about them. I started thinking about environments that users could control with certain equipment in that environment. I wanted the environments to be affordable, modular, and progressively adaptable. You could start with a small piece of equipment and maybe upgrade when you're ready. I thought about having some augmented reality and maybe even a virtual reality world that some users could be in while other users weren't. The end goal eventually became a jam room or immersive art room of sorts, but I'm nowhere near there yet. I also wanted to use the lights to teach about color theory and music theory. I call some configurations of my equipment the world's easiest instrument. I also wanted to allow users to write light shows for their favorite songs. It's difficult to write your own songs, so just write light shows for the songs you already like. So I like to think with my light and sound equipment, you can express a variety of elements: codes, color themes, data, so forth, patterns, rhythms, shapes, symbols, a whole lot of things, really. So here's an overview of the equipment currently in the project. We have several 4x4x4 RGB LED cubes with onboard Arduino. I haven't found the right 8x8x8 or bigger cube for me yet. We have an LED tetrahedron that's over 6 feet tall, made out of 3 polycarbonate tubes and 2 LED strips. One of the strips goes through 2 of the tubes. A unique item is the LED-assisted bass guitar, which uses 1 high-density LED strip to light up frets. We also have several full RGB stage lights. They use the DMX protocol. DMX is a great protocol for anything involving discrete settings. It has 512 channels per universe, and each channel has a value between 0 and 255. This is a daisy-chainable standard. We also have several custom keyboards. This one is used for playing musical chords. You can see all the major and minor chords and the 7 chords contained in the key currently being played. As you can see, no expense was spared. I like the idea and I think it's simple yet very effective. Here's a picture of the LED tetrahedron and LED bass at the Pittsburgh Steam Carnival in 2019. Visitors were able to play and visualize the harmonic structures of songs. Here's some code used to control a DMX stage light, although usually multiple lights are used. As you can see, the code is not object-oriented. In Python, you can, of course, choose between object patterns and procedural functional patterns. Here, the red, green, and blue values are pulled from lists. The DMX channels are set appropriately, and then a rendering is called. Many inexpensive DMX stage lights use 7 channels, so there is room for many lights in the 512 channel universe. We assume here that the single light is set to starting channel 1. The function light multiple is used to control more than one stage light. The function body is not shown here, but one can see that the second parameter is a list of colors. The colors used usually range from 0 to 75, a superset of the colors recommended for use with Seed Studio LED cubes. The assumption is that the lights are set to starting channels 1, 11, 21, etc. The stage lights are usually controlled by a master laptop with a USB to DMX adapter. Such adapters are relatively expensive but effective. This is a picture of a simple interactive lighting installation at Art All Night in 2022. Visitors chose colors using a custom keyboard. The colors swept from side to side. How do we talk to the Arduino board like the ones on the Tetrahedron in the base? For that, a binary protocol for use over USB was devised. The first character is the opcode or command code. Colors are single characters from 0 to 75, again based on the Seed Studio set. Integers are series of digit characters. For example, 901 is character 9, followed by character 0, followed by character 1. Commands are terminated by character 127 because character 0 was reserved for the color red and for the digit 0. Character 255 is another logical choice. For example, what if we have an LED cube set up and we want to make every light on it red? This corresponds to character 33, which is understood on the Python end and the Arduino end. We set command equal to character 33, the opcode, plus character 0, red, plus character 127, the terminator. Then we send a command over the serial port. This is a general function, cubeAll, found in the Python API. The constant cubeAll in all capital letters is abstracted out. The color number argument is converted to an ASCII character before being sent. The Arduino boards process whole command strings after detecting terminator characters. The opcodes are the first characters of the strings. Internal Arduino functions are then triggered. On the Python side, strip range is used to light up a section of an LED strip. To light up LEDs 100 through 200, the start and end parameters would be 100 and 200, respectively. This is to maintain consistency with the binary protocol in which integers are sent as separate digits. To light up every other LED, an increment of 2 would be used. So, this is obviously a Python event, so a natural question is why I didn't just use CircuitPython devices. Well, CircuitPython had just been released when my project started in 2017, and I'm not sure how compatible MicroPython would have been. Also, as CircuitPython devices get cheaper and smaller, Arduino devices will probably continue to do the same, so I went with a Python to Arduino bridge. I now like to show some various project pictures. This one consisted of 3 LED cubes and a custom keyboard. The colors changed in time with the song being played, and users added colors to the list. This worked especially well with songs in 4/4 time. The system was demonstrated at the Cleveland Night Market in 2017. This configuration displays colors associated with major and minor chords. It makes use of an LED cube and 3 stage lights. Users played along with selected songs. The art installation shown here was exhibited at the FireFish Festival in 2019. The user-controlled lights interacted with the sculptural elements, creating patterns that some said looked like fractals. Some Tetrahedron source code is currently available on GitHub. Other source code is available upon request, and it will be released publicly after some code maintenance. Feel free to email me with any questions. Thank you for listening.